Here I'll be doing the live correction of the just concluded NECO theory questions. Instead of doing the correction to upload, I decided to do it live because of time, and also help those that will have chance to participate in this correction. This is a prep for the next people that will write. Or remember that the major thing is to take correction for the future. So these are the questions. Our revision question was a little bit of help, but not as that of biology was so helpful. But all the same, we thank God. So I want to solve these questions, all of them, live with a detailed explanation. So this is a kind of preparing you for future exams. So I am displaying the questions, preparing you for the 2026 NECO exams, because we need to take correction and we learn from our past mistakes, or we actually learn ahead. Okay, so these are the questions. So you are on with Some Majesty's World, or an affiliation with Some Majesty's World. This is a Majestic Tutorials. Okay, so I'll be taking these questions separately or gradually. Okay, it's good we remind you are watching Majestic Tutorials, where top educators deliver simplified lessons across major arts and science subjects. This is a true place, the true channel for expert teachers and impactful learning. As you enjoy this class that we're about to start, don't forget to subscribe and share with others. Okay, here we move with the questions. I'll be as fast as I can. So the first one says, what is fermentation? Fermentation is simply what? A biological process by which microorganisms such as I think that should be number 1A. What is fermentation? You say this is a biochemical process, of course. I said this is a biochemical process by which microorganisms like bacteria, yeast, break down. We are doing revision, of course. Break down organic compounds or decompose organic compounds. Decompose some organic compounds. Commonly sugars, saccharides or polysaccharides, to simpler compounds such as ethanol, and also gases are liberated during the process. That is fermentation. So the next, okay, all right, welcome back. think there is a little distraction, but I'm back. They say with chemical equations only show how ethanol can be produced from starch. Thank you for joining. At least correction time, we don't see many coming. But you that is online, thank you, guys. So we look at they say with equations only. Just use chemical equations to explain production of ethanol from starch. That's the question, and that is fermentation process. So starch can generally be represented with C, maybe C6, H10, H10O6. No, H10O6 is no more carbohydrates. Remember, carbohydrates should contain carbon and hydrogen, oxygen, with the hydrogen and oxygen in the ratio of 2:1. So if this is 10, this is supposed to be 5. Okay, it's just a mistake, and I'm just explaining why such cannot exist. Then, because starch is a polysaccharide plus n molecules of water, which we don't know, to now give us a C12H22O11, of course. So which we will also have the n number of it here. So with this, you have gotten your, remember we are handling the just concluded past question, okay? So with this, you have gotten your, this is breaking starch down to disaccharide, and this is our maltose, okay? So then the next step is that the maltose is also hydrolyzed to give C12H22O11, the second step, but an enzyme works here now, diastase, which we get from malt. Remember, we are not required to mention all this. Then this one is solid, this should be liquid, and this should also be liquid form. All right, so diastase, that's the enzyme from malt. We break it down to glucose and fructose, C6H12O6. But it's because it's hydrolysis, we also need to add water to it again, okay? The process is hydrolysis. So it's going to give us 2 molecules of water. So let me clean off. Plus NH2 of glucose, and that's 2 molecules of monosaccharide, C6H12O6, all right? This is the glucose in question. Please endeavor to write the enzyme diastase. Then the next is that the glucose is diastase works here. The enzymes are confusing me now. I think this is invertase will convert this to this. This one should be, I'll take a look at some sources to get the enzyme, but there will be treatment with yeast whereby the glucose now C6H12O6 will be broken down by zymase to give us a C12H5OH plus CO2, alcohol fermentation. All right, these are the equations that will give us the product. We are moved from starch, where here is our starch, and here is the maltose. All right, I just saw the question, decided to pick them. I'll come back to that now because I'm mixing up the enzymes. So the next question says complete the table. So I think I'm going to complete it here to save time. Remember, those online, ask your question when necessary. So halogen state at room temperature. Fluorine at room temperature is gas. Then uses manufacture of Teflon. So they fuse this one now. Look at these people. Chlorine, the state at room temperature is still gas. They are dashing mark here, okay? So we have how many moles are contained in 25 grams of magnesium. How many moles are contained in 25 grams of magnesium triazocarbonate 4? To solve this, maybe you have to simply find the molar mass of magnesium triazocarbonate 4, right? And the molar mass, they say how many moles are contained in 25 grams of magnesium triazocarbonate 4. The formula is solution. First of all, what's the formula? MgCO3, where M is 24, is given in bracket over here. Carbon is 12, so we have 24 plus 12 plus 16 times 3, which will give us 24 plus 12 is giving us 36 plus 48. Horizontal addition, 6 and 8 will give us 14. This is 84. So the molar mass of magnesium triazocarbonate 4 should be H424 plus 12 plus 48. Let's still confirm. 24 plus 12 plus 48. Well, I'll come back to that. I don't like the nonsense advert. But that's mathematically, this is 6 plus 4 is 14 now. 14, you now take one here. 4 is 84. So 84 grams per mole is the molar mass. Therefore, that means that gram per mole, meaning that 1 mole of it. That means that 1 mole of magnesium triazocarbonate 4 weighs what? 84. So 84 grams is equal to 1 mole. So what will it now be? You now say 25 grams will be equal to X moles. All right. So cross multiply, you have that 84x is equal to 25, such that x is equal to 25 divided by 84. And this will give us let me disconnect this. Okay, we are looking at 25 divided by 84 is 0.297, 0.298. If you approximate, 0.298 moles. That's the answer. So then the next question says, name the suitable indicator for the titration of strong acid. Let me confirm if the molar mass is correct. 24 plus 12 plus 48 is 84. So that's correct. The next one says, name the suitable indicator for the titration of strong acid and weak base. You use methyl orange. Why? Because of the pH transition range. pH, that's the range, the pH range at which indicator changes color. We see it as pH transition range, because the pH transition, when you hear choice of indicator, is because each indicator has a range at which it changes color. So the pH transition range is equal to what? The pH transition range of the indicator is within 3.1 to 4 as the pH transition range. And then this, since the titration is between a strong acid and a weak base, they will form a salt that will hydrolyze to give an acidic solution. Most of you might think that every neutralization must occur at pH of 7. It's not true. So if you use pH of if you use phenolphthalein, you'll be expecting your neutralization to occur from 7 and 8, which is the transition range of it. But it is universal indicator that if you use it, your neutralization will be at 7 on the dot when the color is green. You can visit Sa Majesty Easy World Science channel to watch the real experiment on the effect of the choice of indicator used in titration. But just know that methyl orange is the answer. Then the reason why we use methyl orange in strong acid and weak base, because acid wins. They will form salt, but the salt they will form is going to hydrolyze to give an acidic solution. So a salt of strong acid and a weak base will hydrolyze to give an acidic solution. So we will use an indicator that have a pH range within the acidic side. While the titration between weak acid and strong base, we will use an indicator that have a pH transition range within the basic side, because it will form a salt of a weak acid and strong base, which will hydrolyze to give us a basic solution. That is where phenolphthalein comes in. All right. So even though it's not even ideal to use methyl orange when you titrate strong acid and strong base, but we often use that. The ideal here should be phenolphthalein and or also a universal indicator is the best, okay? Though we often say that strong acid and strong base can accept any indicator, but that's not really the best in practical, okay? The next one say give an example of an acidic oxide. Acidic oxides are oxides of non-metallic oxides that dissolves in water to form acid. Those acid anhydrides, example SO2, CO2, NO2. So these are acidic oxides. Then the next one say neutral oxides. Those oxides that don't have effect on litmus, they are neither acidic nor basic. Example is laughing gas, carbon 2 oxide. Remember, carbon 2 oxide is neutral, while carbon 4 oxide is acidic. So, and then finally water itself. Remember that water is an oxide. So water is an oxide. So an example of acidic oxide, SO2, CO3, and NO2, I told you they are acidic oxides, while the neutral oxides are the laughing gas, that's nitrogen 1 oxide, carbon 2 oxide, and water itself. They are all neutral. Then give one difference between hydrophobic and hydrophilic compounds. The word hydro is water, then phobic means hating, then philic means loving. So hydrophobic compounds are compounds that are very much soluble in water, and they are water-loving compounds. They dissolve in water, like ionic compounds. Most ionic compounds are hydrophilic. Hydrophilic is what I'm explaining. Hydrophilic, water-loving. Those ones that are soluble in water, like soap, is hydrophilic compounds. They are the ones that dissolve in water. I've broken down the term hydro, water, philic is loving. So they are water loving compounds. They are highly soluble in water. Example, the ionic compounds like sodium chloride, the soap you use for bathing. But when you come to hydrophobic compounds, they are the water hating compounds. If you have heard about phobia, xenophobia, where you hate strangers by some countries exhibiting, so we do hear such things. So just know that phobia is the hatred, the texting, the fear of something. So a kind of water hating. So this includes the covalent compounds, those ones that don't mix well with water, such as benzene, and equally, most hydrocarbons, they are hydrophobic. So they are water hating, they don't dissolve. So one difference is that hydrophobic compounds are insoluble in water, while hydrophilic compounds are soluble in water. As simple as that. Solubility. Then the next one is write the IUPAC name of the following compounds. Write the IUPAC name of the following compounds. In my live stream, I taught this yesterday, only that maybe network could allow some people to get that. If you are to name this, you have to find out the longest continuous carbon chain, which are 1, 2, 3. So these are 3 carbons, and the principal functional group is COOH, and there is no branch. So this is nothing but propanoic acid. Propanoic acid. Propanoic acid. So that's the name of the compound. If you are finding it difficult to name, you can expand it, maybe kind of draw it larger. How do you do it? This is 1C. Expand it by putting H all over, because there are H3. Then you move again to the next C. Put 2 hydrogens on that C, up, down. Then you move to the next C, double bond. Okay, you have double bond O and OH. That is propanoic. Prop 1, 2, 3. 3 is prop, while 2 is et, 1 is met. So because of the root is prop. Then what's the suffix? COOH is acanoic acid. So you have propanoic acid. So that's the name. Then we'll move to this one. Is also simple. The principal functional group is OH. You count 1, 2, 3, 4. 4 is but. 4 is but. So we have butanol. But the OH is at carbon number 1. So you say butan1-ol to be on the safer side. So this one is 1-butanol or butan1-ol. Butan1-ol. Or you can say 1-butanol. That's the second one. They now say, define the rate of chemical reaction. What is rate of chemical reaction? Rate of chemical reaction is the rate at which the reactants are converted to products. Rate of chemical reaction is the rate at which reactants are converted to product. The rate at which reactant particles are converted to product particles. That is the rate of reaction. Or you can say is just the mass of product formed all over time of the formation of the product. Okay, it is actually the thing that measures the reaction kinetics. The speed of the reaction is just the rate, which we can only assess by measuring the mass converted all over time of conversion. Also the product formed all over the time of production. So says the rate at which reactant particles are converted to product particles. Then the next one is state 3 factors that affects the rate of chemical reaction. This is very simple. There are more than 3 factors, so we have many of them. Factors that affects the rate of chemical reaction. Number 1, temperature. Then number 2, concentration. Number 3, catalyst. Number 4, nature of reactants. Nature of reactant particles. Number 5, we have nature of reactant particle. Then we have surface area, and so on and so forth. These are the factors that affects the rate of chemical reaction. You can pick even light intensity for photochemical reactions. Then pressure somehow is not too effective. Remember that catalyst has no effect on the equilibrium position of a reversible reaction, but it affects the rate at which reversible reactions attain chemical equilibrium. We are done with this page. Okay. So we go to the next page. Okay, all right. Welcome. Don't know the little technical error. I'm fixing it now. I believe it's done now. Okay. So nice to have you back. Nice to have you back. We go to the next question. The next one says, what is an acid anhydride? What is an acid anhydride? Literally, acid anhydride means acid without water. Okay, I talked about it on my live stream yesterday in the revision class. An acid anhydride is a non-metallic oxide that dissolves in water to form acid. To form acid or acids. You can also say that acid anhydride means acid without water. Yes. Is just an acid without water, but here doesn't specify if it is an oxide or not. So this one is kind of not being more specific. Okay, not being more specific whether it's an oxide or not an oxide. All right. So we go again, whereby the next one says, these are just non-metallic oxides. When I was giving you examples of acidic oxide, I mentioned it. So all the acidic oxides, though they didn't ask us example, SO2, CO2, NO2. If they give you an acid to find the acid anhydride, I repeat, H2SO4, just remove the H and one oxygen here. So what will remain is just SO3. So SO3 is also an acid anhydride, while H2SO3, the acid anhydride is SO2. How about carbonic water, that is triazocarbonate 4 acid, the acid anhydride is CO2. So this is also applied in the preparation of acids. Preparation of acid can be prepared by dissolving the acid anhydrides in water. So if you say CO2 plus water under the necessary condition, you get H2CO3. All right. Now the next one says, give 2 examples of a weak acid. Weak acids. It's good to let you know that all the acids that the name ends in oic or that ends in COOH are all what? They are all weak acids. Even if you don't know before now, know it. An acid that the name ends with oic or COOH. For example, all organic acids are weak acids, and they are the acids that we call carboxylic acid. So, but you can start with the common one, ethanoic acid, lactic acid, the one you see in milk, citric acid. They are all weak acid. Even benzoic acids are weak acids. Then you can come to mineral acids that are weak acids. Examples of such acid is carbonic water, H2SO3, weak acid, but H2SO4 is a strong acid. Then H3PO4, a weak acid. Even HF, very corrosive, but it's still a weaker. acid. They don't dissociate completely. Then the next one say give one difference between fats and oil. At least fat is solid at room temperature, oil is liquid at room temperature. Fats are unsaturated, oils are saturated. So these are the major thing that distinguishes fats from oil. At least their states at room temperature. Fats are solids at room temperature. Why? Please, you take a look at their states of matter. Fats are solids at room temperature, while oils are liquids, even though some of them might be volatile. Liquids at room temperature. So then I told you again that fats have is unsaturated while oil is saturated. Then I say write the structure of the following: hydrobenzene, 1,2-dimethylbenzene. 1,2-dimethylbenzene, that's what we call xylene. Though if they have said xylene here, some might get it confusing. Xylenes are just double a dimethyl compound of aromatic compound, dimethyl. You know that methylbenzene is toluene, but when we have more than one methyl group attached to a benzene ring, we call it xylene. So but let's go with hydroxybenzene. First of all, they say the structure. Be careful, make sure you are going to give us 6 vertexes. Make sure there are 6 edges. It's not anything you draw goes, okay? It is not. We have this. And this, right? So, and then either you use the resonance structure or you use alternating double bond and single bond. Then you find any carbon and put OH. That is hydroxybenzene, which we can also call phenol. Hydroxybenzene is also called phenol. Okay. Then the next one is 1,3-dimethylbenzene. 1,3-dimethylbenzene. This one is called phenol, and you can also call it hydroxybenzene. I think I gotta clean this. Let me shift it so we can have space to write hydroxybenzene. Then the next one says 1,3-dimethylbenzene. I call this thing xylene, and 1,3-dimethylbenzene means also M-benzene. You watch, okay, that should be at some agencies where I'll make more tutorials. Say it is also called M-dimethylbenzene because it's a di-substituted compound of benzene. It is a di-substituted compound of benzene, meaning if there is substitution of the 2 hydrogens in benzene, remember benzene is C6H6. Normally, each vertex will have 6 carbons and will be attached to only one hydrogen, which means if I should draw the real structure itself, remember you can also draw this. It is also accepted structure of benzene, but make sure you attach alternating double bond and single bond. After double bond, jump, keep single. Then after single, double, double, single, double. That is benzene. Now each one here is H, so that we will have that C6H6. But what happens if I substitute only one hydrogen here? Is easy to name, like the hydroxybenzene with OH, it becomes phenol. But if I substitute 2, we call it di-substituted compounds of benzene, okay? And we use the letter M for meta. We use also auto and then para. So when it is in 1,2 position, we call it O2. When it is in 1, 3, meaning let's assume I put X here and put the same X here. If I want to describe it because they are adjacent to one another, I'll say O2. But when the X is not here, but just here and here, this is 1, 2, 3. This is 1, 3, just like this. Meaning if I put chlorine here and put this chlorine here, that's what they want us to, let's assume this is chlorine. This becomes 1,3-dichlorobenzene. Instead of wasting time to say 1,3-dichlorobenzene, you can just say M-dichlorobenzene because it has the meta position, 1,3 position. Then what if the chlorine is not here, but here? It is now at carbon 1, 2, 3, 4. We call this one para. So auto, meta, para. Auto position is 1, 2. Para position is 1, 4. Meta position is 1, 3. So the summary is that this 1,3-dimethylbenzene simply means M-dimethylbenzene, meaning methyl group, two methyl groups are attached to the benzene ring. Each they skipped one carbon away from one another, but when they are next to each other, we call it auto. All right. So to draw this, remember met is 1. Put methyl. Put this CH3 at carbon 1 and carbon 3. Which one is carbon 1? And now, maybe let me make it look nice. Okay. Unfortunately, it ain't looking nice as I thought. Well, let's go. Excellent. So we have this. Then you can put circle here. Anywhere, if you like to put CH3 here, just jump here and put another CH3. This is dimethylbenzene. But if you put your first CH3 here, let me reverse all I did now. CH3 is my methyl. If I decide to put CH3 here, I would skip and put it here. So any one you use is still dimethyl. What if I put it here? I'll now put next here. Another way is that you can also just skip one carbon. Let them be one carbon apart from one another. Because each vertex is, if I put CH3 here, I either put it here or here. It is still 1, 3. All right. So whichever one you like. This is 1, 3. And we call it xylene, so we can commonly call this M-xylene, meaning that the methyl groups are at carbon 1 and 3. So, but don't write this one for them, just write it 1, 3 dimethylbenzene according to the question. All right. Then the next one is give 2 physical properties of ethine. Physical properties of ethine, very simple. Ethine is a gas at room temperature. It is colorless. It is lighter than air. Should we check? Yeah, C2H2, which should be 24 plus 2, which is 20. So it's lighter than air, of course. It's insoluble in water. It is neutral to litmus paper. Okay. Then it is flammable. The next one says calculate the volumes of 0.2 mole per dm cube solution of tetraoxosulfate 6 acid that will contain a mass of 3.5 gram of the acid. The volume that will contain 3.5 gram of the acid. So I am looking at this. Calculate the volume of 0.25 mole per dm cube solution of tetraoxosulfate 6 acid that will contain a mass of 3.5 gram of the acid. So we are going to convert this mole to mass, or we rather convert this mass to mole to make these two units be to make the two values to be in the same unit. Okay. Remember, you are on with Majestic Tutorials, of course, where we'll handle you in all the major subjects across arts and science. Okay. before I solve this, we are going to look at the compound in question is tetraoxosulfate 6 acid H2SO4. Be careful, tetraoxo, not when they say trioxo. So looking at III, first of all, molar mass of H2SO4 is equal to 98. I already know that. That's what it is. So what if I decide to convert mass to mole? All I know is that I'll make all of them in mole or make all of them in mass. I guess let's work all in mole because the lower the value, the easier to calculate. This implies that 98 grams of H2SO4 represents 1 mole of H2SO4. What will 3.5 grams represent? X. To represent 98x is equal to 3.5 times 1. Divide both sides by 98 by 98. Remember, this is times 35 times 1.0. So when you do this division, we will have that 3.5 divided by 98 is, looking at the calculator department, 3.5 divided by 98. 3.5 divided by 98 is 0.0357. 0.0357. 0.0357. 0.0357 moles. Okay, we can now go back to the already mentioned statement here. They said 0.2 mole per dm cube. Okay, calculate the volume. So it becomes very simple. 0.25 mole means that 0.25 is in 1 dm cube, and 1 dm cube means 1000 cm cube. So if eventually that the volume that is capable of holding, maybe we'll try to lift this calculation. Okay, so we can continue here. So this implies that 1000, or rather that you can use any volume, of course. Use 0.25 moles is contained in 1000 cm cube. What was the mole we got? 0.0357, or you can say 0.04 to work according to their figure. Can maintain their figure. They gave us two significant figures, 2 and 5, so 0 and 4. But if you keep more than that, there won't be any problem. So that our x, you cross multiply, 0.25x is equal to 0.0357 times 1000. So looking at this calculator department, divide both sides by 0.25. 0.25 cancel. So 0.0357 times 1000 can go with our calculator. We shift 1, 2, 3. Okay, that will give us 1, 2, 3. That will give us 1, 2, 3. That should be 5 points. Okay, let me, my head don't fool. Times 1000 is 35.71. Yeah, that's what I was doing. 1, 2, 3. 35.71. So we have 35.71 all divided by 0.25. Then divide it by 0.25 is 142.85. 142.85. All right, so we have 142.85 cm cube. That's the volume of that gas that will contain 3.5 grams of the acid. Then 0.25 means what? Let's check. Because we are having lesser volume, to give us 3.5, which means if we convert this to mass, it will be more than 3.5. 0.25 times 98 will give us that mass. If you want to work in mass, which is 24, so they are correct. Our answer is in order. So the next question says, state the periodic law. I think that's the next thing. State the periodic law. Periodic law is also called modern periodic law or the Mendeleev's law. Mendeleev's law states that the properties of the chemical elements are periodic function of their atomic number. Okay. Periodic law states that the chemical and physical properties of the elements. We are advised to just say of the chemical elements because we have elements of darkness. I don't know, but this is chemistry. Anybody mentioning elements already know we're talking about chemical elements. They say periodic law states that the chemical and physical properties of the elements, I will speak wrong English here, are a periodic function. It looks so how, but that's what it is. Periodic peak. Hello, welcome back. They said the chemical and physical properties of the elements are periodic function of their proton number, and proton number is also called atomic number. So now we move on. That's the statement of the law. Remember, we call it Mendeleev's law. The next question, which is CII, say copy and complete the table. Copy and complete the table. Let me write straight on that table. On the questions here, remember I just picked a student's answer script after exams. So the person's trial is what we are seeing here. They say aluminum is 13. They gave us the sample. You just write it now. 1s2, 2s2, 2p6, 3s1 and 3s2, sorry, and 3p1, 3s2. So let me write it where you will see it where electronic combination of aluminum is 1s2, 2s2 because it's 13 now, 2p6 and 3s2. That's 12. Finally 3p1. If you calculate, this is 2 plus 2, 4 plus 6 is 10 plus 2 is 12 plus 1 is 11. That is it. If you are online and you want me to solve any particular question for this thing I'm doing, you can request. Thank you guys for being there. But I'm solving them gradually. Then what's the valency? Valence electron. Valence electron is the electron in the last share. The last share electron is, how do we know the last share electron from this configuration? Hello, man. See, you just see these three, the last three. 3, 3. So 2 plus 1 is 3. Okay. Is 3. That's the valence. So if you know about 283 also is giving you that 3 also, but in this case just count those ones. You see that we only used 2 here because the last thing is 2. We can't sum 2 plus 2 because this one is in the inner share. Valence electron is the electron in the last share. How do you know the last share? Those ones sharing similar number. 3, 3, that's the last share. They are all in the period 3, the K share. I mean KLM. They are all in the M share. So the thing is 3. Then looking at potassium is easy. You also write it SSP, SPS, 1, 2, 2, 3, 3, 4, 1s2, 2s2, 2p6, 3s2, 3p6, then 4s1. 2, 2, 4, 10, 12, 18, 19. So that's it. Now, what's the valency electron from what I told you? The last highest number is 4. We don't have another 4 again, so which has only 1 electron here. So it is also 1. The next one say consider the elements A, atomic number 3, B, atomic number 11, C, atomic number 13, and 17 for D. Let's see the follow-up question. So permit me to clean this so that we can get the message well. They now say which of the elements which of the elements has the highest electronegativity. Electronegativity is the tendency to gain electron or the tendency to control shared pair of electron more than the other atom. Okay, the ability to withdraw, the electron withdrawing ability of an atom in a covalent bonding, we call it electronegativity. All right, so or the ability or the tendency of an atom to attract electron attracting ability to form negatively charged ions. So we say which of them is highly electronegative. We take the metal first. This one is lithium, which is 2,1, is the least electronegative. Sodium is also least electronegative. They are more electropositive. So the correct answer is chlorine, which is 17. How do we know non-metals? Those ones that their configuration end in more than 3. If you look at chlorine distribution, 287 in the last share, 7 is more than 3, so it's a non-metal. But if you check all these 3, they are all metal. A, B, and C are all metal. Why? Because they have less than or equal to 3 in their last share. Okay, so your correct answer to this one is D. Remember not to tell long stories. So extra sheet in chemistry is always a sign of you writing nonsense. Then the one that belong to the same group in the periodic table, you can see lithium and sodium. You just write A and B. Why do they belong to the same group? Because they have the same valence electron. If you want to share that of A, which is 3, you say Kl, which is 2 and 1. That of B, which is 11, you say Klm. 281. They all ended in 1, so they are all in group 1. That's lithium and sodium actually. But don't write lithium and sodium in exam. Write according to the alphabet in the question. Don't go telling them that you know that D is chlorine, or you go and change this A to lithium. Write according to the information given to you. All right, we now move on. They say mention one non-crystalline form of carbon, that is the any amorphous carbon. You can say as many as you can: sugar, charcoal, or just charcoal. Okay, then lamp black. You have also soot. I think these are the common ones. Don't call diamond here. Don't call graphite. Don't call bucking balls or Buckminster fullerene. They are all crystalline. They have definite shape. Or you can also say coke is part of it. Yeah, if you call coal, it's part of amorphous, but coal is just a mixture. All right, but call coke, charcoal, soot, and lamp black. So these are all amorphous carbon, meaning non-crystalline, amorphous, without a regular shape. We go to the next page. But before then, I say I'm gonna visit this first page for this particular fermentation. I couldn't they say what is fermentation. I was misplaced. I mean, look, I defined that one where it was this equation where I was confusing the enzymes. I think let me try and correct it now. The first one is conversion of the starch to maltose, and the enzyme that does this is diastase. So diastase is one of the first enzyme to be discovered. So I want to use the equation again, or maybe no need of repeating, but they said equation. So C6H10O5, you have 2, then bracket N to show that it is a polymer plus NH2O. What I'm just correcting is the enzyme involved. This is diastase, which was discovered by St. Paschem also. Yes, and then finally it will give you now the C12 H22O11, which is our maltose. Then the maltose is broken down to glucose by, that's where maltase. Remember, if you replace, watch this, maltose, O's, sugar, ACE, the enzyme that digests the O's. For example, if you have sucrase, is the enzyme that works on sucrose, O's for sugar, ACE for enzymes, okay? So then finally the glucose is broken down to give you ethanol by zymase. I was correct there. I believe I've set this clear now. Okay. Let's jump to the next. We're done with this. The next one says, define entropy. Entropy is the degree of disorderliness of a system. Calculate the vapor density of oxygen with a volume of 0.25. Please, entropy is the degree of disorderliness of a system. You can take it as how scattered something is. Watch this. If we have this molecule now, that this is sample A, you see, this is not scattered, it's organized. Then we have another sample B. This is somehow, it doesn't have any, it's not giving us any uniform shape. Work business, say hi. Hi too. Do you have any question? If you have, you ask, okay? Then the next one is, what am I teaching? I am handling the just concluded NECO theory questions, chemistry, okay? You watch the title of what you clicked, and also the thumbnail is showing clearly well, okay? Your job is to ask your questions. I displayed the questions before resuming. Look at the questions there on the screen. So, and I'm defining entropy. I say that entropy is the degree of disorderliness of a system. How disordered, how scattered something is, or we can see it as the system's unavailability or inability to do work, okay? So when you look at this, I'm using to teach you, see, this is very much arranged and not scattered. This is very much ordered. Particle or substance A is very much ordered than substance B. But what if we have another substance that is, see, this one, substance C, have highest degree of entropy. So if you come to states of matter, gases have the highest entropy, followed by the liquids. Solids have the least entropy because solids are very much organized. They are not random. So the degree of disorderliness, they are not disordered. Solids, like you see this, my pen, I'm holding it well, is very much ordered. But if you mistakenly pour water, you cannot say, let me go and pick up this water that I pour, because it is disordered, okay? Water is liquid. What if somebody eventually releases a gas that is not supposed to be released? You cannot say, please bring back that gas to me, let me pick the gas. No, it will scatter everywhere because it has least force of attraction. The cohesion force seems to be very much small to compare to solid and liquid, okay? Calculate the vapor density. Please, it will be okay to introduce you back to what you are watching. You are still on with the Majestic Tutorials, the home of academic excellence. This video is meant to prepare you for the next exam. Remember, it's a trusted place for exam success. 100% against malpractice. We teach you how to fish, we don't give you fish, all right? So we are just handling the past question. And again, we are here for you across all the subjects. Your job is to subscribe and share this video. You can also request for special classes. We are here to serve you and make you pass the exam by yourself. Thank you. As we go back to the question, this is the page I'm into. I will facilitate my answer. I've answered entropy. Calculate the vapor density. Remember, vapor density is equal to molar mass divided by 2. Calculate the vapor density of oxygen with a volume of 0.28 dm cube weighing 0.4 gram at STP. They have mentioned STP, a standard condition which will help us to do what? Calculate. Now, the mass of 100 cm cube of hydrogen at STP 0.090 gram. Let me take the question again. Calculate the vapor density of oxygen with the volume of 0.28 dm cube weighing 0.4 gram at STP. Having mentioned STP, why not give us 22.4 dm cube? And they are giving us the density of hydrogen gas. Anyway, any of them can work. Yes. I can solve with this value here. I can also solve without this value in brackets and still get the same answer. It should be that way. Let's try out something. But in exam, please solve with what they gave you in brackets. You are expected to use this one to get the answer. All right. So I want to maybe I want to solve it right here on this on the answer on the question paper itself. I'm taking a look at this question, maybe 2AI. So calculate the vapor density of oxygen. I already said that vapor density Vd is equal to molar mass divided by 2. That's if they want us to go to molar mass aspect, but they don't want us to do that. Now, also, vapor density, yes, is also the number of times a given volume of a gas is as heavy as the same volume of hydrogen. So, it's also equal to X volume of a gas all over X volume of hydrogen, sorry. That's X here is telling us the same. So because hydrogen is the lightest substance, if I am 3 times heavier than hydrogen, then my vapor density is 3. That's the meaning. If I am 0.5 heavier than hydrogen, which is not possible, is the lightest gas known. Just know that if I am 10 times heavier than hydrogen, my vapor density is 10. If I am 2 times heavier than the same volume, meaning if you bring, for instance, 200 cm cube of X as a gas, and also bring 200 cm cube of hydrogen, and you discover that 200 cm cube of this gas weighed 20 grams, while the 200 cm cube of hydrogen gas at the same temperature and pressure weighed 4 grams. Guess what? The vapor density of this gas X is equal to 20 divided by 4, which gives you 5, which means this gas X is 5 times as heavy as hydrogen, the same volume of hydrogen gas. Okay, so they want us to use this one to solve that vapor density is equal to the number of times a given volume of a gas is as heavy as the same volume of what? Hydrogen at the same temperature and pressure. So this is what we are expected to use to calculate. I will use this and also use the one that relates vapor density is equal to molecular mass divided by 2, or molar mass divided by 2, or relative molecular mass divided by 2. So in this case, I want to go with the easy one. Having said this, 0.28 dm cube of this weighed this, then I have to find out, I have to give hydrogen the same volume that was given to oxygen, 0.2 dm cube, and the question already told us that 1000 cm cube weighs this. So I'm going to just write solution, which means if 1 dm cube, can somebody know why I'm using 1 dm cube? Because 1000 cm cube is equal to 1 dm cube. If 1 dm cube hydrogen gas weighs what? 0.090, what will 0.28 dm cube weigh? Whatever it weighs gives us the equivalent mass for the same volume of what? Oxygen. So from the mathematics, we now have that X is equal to 0.28 times 0.090. From the calculator side, we have 0.28 times 0.09. 0.28 times 0.09 is 0.252. Okay, you have 0.252. 0. Let me look at it again. 0.0252. 0.0252 grams. So it's now we have seen the mass of the equal volume. The question already told us that 0.28 dm cube of oxygen is 0.4. We have now seen that the same volume, 0.28 dm cube of hydrogen, is 0.025. Now, for us to find the vapor density of that gas, vapor density of what? Oxygen, will now be the mass, which is 0.4 all over 0.025 what? 2. Because it says the number of times a given volume of a gas is as heavy as the same volume of a hydrogen at the same temperature and pressure. It's conditional. So I will go to my calculator and now find out. So 0.4 divided by 0.0252 is 15.87. So that's the vapor density, 15.87. No unit. That's the vapor density. I hope you know this can be approximated as 16. Now, another method is 22.4 dm at STP. Alternatively, I can now say that at STP, alternative way, at STP, 1 mole of any gas is 22.4 dm cube. And they have already told us a volume and mass. Therefore, we will just simply say if 0.28 dm cube was able to weigh what? 22.4. Was able to weigh 0.4. Was able to weigh 0.4 gram. Whatever 22.4 dm cube weighs is the molar mass and not the vapor density. Please take correction here. So when you cross multiply, it becomes 0.28x is equal to 22.4 times 0.4. Okay, such that x will now be 22.4 times 0.4 all divided by 0.28. All things being equal, we are expected to get exactly the same 15.87 or 16 or 15.9 or so, just within the range. Okay, so 22.4 times 0.4 divided by 0.28. Let's go. 22.4 times 0.4 divided by 0.28 is giving us 32. Okay, 32 is the molar mass. Very correct. So we have 32 grams per mole. Now remember in the beginning where I told you that vapor density is equal to molar mass divided by 2. So we have gotten molar mass as 32. So we now say Vd is equal to 32 divided by 2, which is 16. So it's rhyming well. Yeah, that's nice. So 16 and 15.87 is giving us the same, but please use the first one. That's why they gave you that figures in brackets. Okay. All right. Thank you, guys. Thank you. We move to the next question, which says, given the equation N2 plus O2 to give you 2NO, state one factor that will bring greater yield of the product. Remember, pressure will have no effect here. Don't mention increase in pressure. Don't mention that. And don't mention catalyst, because catalyst has no effect on the equilibrium position. They say the yield of the product. Since the reaction is reversible, equilibrium will not give us more of the product, neither will it give us more of the reactant. So catalyst is unbiased in action. Whatever catalyst do to the left hand side, that's what it does to the right hand side. So catalyst is unbiased. Because of the unbiased nature of catalyst, it cannot favor any side. It's a neutral man in a reversible reaction. And why can't we say change in pressure or increasing or decreasing pressure? Reason, there are equal number of moles of gases on both sides of the equation. If you look at here, we have 1 mole. Watch how many moles are here. 1 mole of air, 1 mole of nitrogen gas plus 1 mole of oxygen. 1 plus 1 is 2. And here we have 2 moles of nitrogen, 2 oxide. So nitrogen 2 moles. So the total mole on this side is 2 and the total mole on this side is 2. So when there are equal number of moles of gases, pressure changes will have no effect. Rather, now this reaction, what we judge it is this heat change they gave us. The heat change they gave us here, they told us that it is positive. So the heat change is endothermic, meaning the forward reaction is an endothermic reaction. In any equation like this where they give you heat change, it is for the forward reaction. It means that when nitrogen combine with oxygen to give what? Nitrogen 2 oxide, that this heat change is positive, meaning the heat change is going to be greater than 0. In other words, it will lead to what? Absorption of heat from the environment and not evolution of what? Heat. Now, for this, forward reaction will give us NO because that's the product. Here is the product according to the question. Simple, increasing the temperature is the correct thing. So what is, they say state one factor, increase in temperature or increasing the temperature of the reaction. Anyone? Increasing the temperature of the reaction will lead to automatically more yield of nitrogen 2 oxide according to this equation. All right, give a reason for your answer because the reaction, the forward reaction is exothermic, because the forward reaction is endothermic. Make it as a statement, but let me be fast. You just write in your answer script because the formation of product is due to endothermic. So if something is cold, you can heat it and favor it. So increase in temperature favors endothermic reactions, okay? But this favors exothermic reaction. Mention 2 uses each of the following. Tetraoxosulfacic acid is used in manufacture of fertilizer like ammonium sulfate. It's also used in production of use it in lead acid accumulator. It is used in the laboratory as drying agents. They did not limit to, they say 2 uses. So you can use it as drying agents in the laboratory. It's also used as dehydrating agents in the laboratory. Then industrially, it is used in manufacture of fertilizer. It is also used in making a lead acid accumulator. That's the car battery or wet cell or secondary cells. Then what is the use of diamond? Jewelry. Diamond is used as jewelry. Diamond is also used to cut hard tools as abrasives to sharpen hard tools. We also use diamond to build drills, okay, and as a support for precision instruments. But jewelry is one of the good use of diamond. Then carbon dioxide. What are the uses? Carbon dioxide is used in production of aerated drinks where it gives it the refreshing taste. And carbon dioxide is used as a fire extinguisher. Dry ice can also be used to preserve. The same dry ice. Dry ice means solid carbon dioxide. You also use it to produce a smoke illusion in a stage performance. So because it's sublime, so when you open the dry ice, it can create a whitish smoke which is harmless, which can be used in entertainment. Remember I said it's used as fire extinguisher. Carbon dioxide is used in production of aerated drinks. They now say give 2 examples of normal salts. That's so simple. Sodium chloride, sodium tetraoxosulfate 6, and so on and so forth. Copper 2 sulfate, they are all normal salts. Even lead 2 sulfide is a normal salt. Even though it's a sulfide, it's a normal salt. Then state 2 physical properties. So you know that normal salts are formed when the replaceable hydrogen ions of an acid are completely replaced. There is no hydrogen left for them. But if I write NaHSO4, this is an acid salt and shouldn't be there. State 2 physical properties of benzene. Benzene is colorless, a clear solution. It has a very kind of faint sweetish smell, and then it is very flammable. It's flammable. That's benzene. Then it's neutral to litmus paper. They now say name the compound below. Name the compound below. Follow the rules. For us to get the IUPAC name, let's count. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. From all angle. 1, 2, 3, 4, 5. Remember, you can take this direction. Another person can take this direction. Both of you will get exactly the same name. All right. So in this case, we have gotten 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have pent. Pent. That's the root. And then in that pent, we have single bond throughout. And when you have single bond throughout, we have ANE. So we have our pentane first. Then it's time. Oh, it's not pentane, sorry, brother. Because over here, I neglected this. There is OH. So the OH will make me remove the E in the pentane and place OL, which makes it all. But which carbon bears the OH? This is time to identify the position of the OH. How did I get pent? Pent is 5. You know your mathematics, pentagon, hexagon, heptagon, octagon. But in chemistry, we are nice people. We don't shoot. We remove that gun. Don't mind me there. So we just have pentan. It is at carbon number 2. How do I say 2? Start from here and count 1, 2, 3, 4. You spent 4 places before. You counted 4 before getting to this. But if you start here, 1, 2. So the shorter one is 2. So take the end that is closer to the principal functional group. So pentan 2-ol is, we have gotten the root and the suffix. Then having said that this is pentan 2, automatically this is carbon 1, 2, 3, 4, and 5. So when you look at this, carbon 1, 2, 3, 4, 5, this implies that we will check at carbon 1. Do we have any substituent group? We don't. Carbon 2, we don't have substituent group. Rather, what we have is functional group, which I highlighted. Then at carbon number 3, do we have a substituent group? Do we have anything taking the position of hydrogen? Yes, we have. And this substituent group is CH3, which is called methyl. So we have seen a methyl at carbon number 3. So for us to describe this branch, we must use the number from where it occurred. So it occurred at carbon number 3. So we'll say 3-methyl. When we go to carbon 4, we still see another branch, which is methyl. So at carbon number 4, there is a branch called methyl. So we have now 3-methyl, 4-methyl. But because they are all methyl, we will simply just say factorize them. It becomes 3,4-dimethyl pentan 2-ol. All right, 3,4-dimethyl pentan 2-ol, and that is the IUPAC name. See what you don't want to do. Never you say to number backwards. This one, backward numbering, was correct because that's what the structure gave. There are conditions where you number left to right and you still become correct. So I'm not teaching you to number backwards or forward. No, number from the end closer to the principal functional group. State 2 ways of preventing chemical degradation. This is a big grammar. Chemical degradation. Which one be this one now? Chemical degradation. Okay, now that means just anything to prevent unnecessary chemical reaction, maybe like natural reactions. You need to reduce undesired things because chemical reaction like rusting goes on. Yeah. So when iron rust, it has been degraded now. So we can prevent that by painting or electroplating. Yes. Or normally, because we have oxygen in the air, which is very reactive, we can use antioxidants. Yes. Even electroplating, like I said, I don't know if I've mentioned it, we prevent this. So you can say electroplating here, or equally painting it, or using an antioxidant. Okay. Or coating of, it must not be we can coat the surface with something less reactive so that it will not degrade. Then also preserving in the suitable environment or preserving in a suitable medium or solvent. For example, to prevent chemical degradation of sodium, you need to protect it from oxygen, excluding oxygen by storing it in paraffin. I just wish I'm getting the mind of who said the question. Mention 2 allotropes of carbon used as conductors. Mention the allotropy of carbon used as a conductor of electricity. Now graphite now. Okay, that is the allotropy of carbon used. Then we have the next one. Say, what is basicity of ethanoic acid? Anything anoic acid without having dioic, trioic, but just anoic acid, the basicity is 1. Ethanoic acid, propanoic acid, and so on and so forth. This is where I'm going to draw the curtain. So they say, name one example of these strong electrolytes. They are strong acids, such as, the basicity of this is, you can say mono basic, or you say just 1. Okay. Then strong electrolytes, they are all strong acids, such as H2SO4, HCl, soluble salt like sodium chloride. Weak electrolytes like the ethanoic acid, they just say they're all the weak acids. Then water itself is also ammonium hydroxide. Even water is also a weak electrolyte, okay, because it doesn't ionize completely and it has a low electrical conductivity. So remember, you are still watching the Majestic Tutorial, your reliable place for academic success. Okay, I think there are much of other questions remaining which are interesting, but we might take them in another live stream. I gotta go to catch up with other classes, private engagements. Thank you for watching. For those of you coming and somebody that have been there throughout the beginning of this live stream, I say God bless you. Then you that just joined and start watching, God bless you also. You never know when this happened. I know that's why you did not join when it was happening, but you are still free to ask your question. You're watching Majestic Tutorial, where top educators deliver simplified lessons across major art and science subjects. A true hub of expert teachers and impactful learning. As you enjoy the class, or as you have enjoyed the class, don't forget to subscribe and share with others. I cannot do without you. Much love. Bye for now.